All right. So we are here to talk about AWS Glue and auto scaling, specifically around how to manage capacity with the use of the newly announced feature on auto scaling. So first of all, my name is Kinshuk Pare. I'm a principal product manager on AWS Glue. Here's the agenda for today. We'll talk about what is AWS Glue for those who don't know what is AWS Glue. We'll spend 7 to 8 minutes getting into the mechanics of how Glue operates, what are the key capabilities. And then we'll dive right into the auto scaling feature. Why do you need it? What are the problems that we are trying to solve? And how does it work with a couple of scenarios? So AWS Glue is a serverless data integration service. It's simple. It's massively scalable. It allows you to integrate data faster at scale without any servers to manage. It's specifically for the purpose of application development, machine learning, and it integrates at scale. So some of the key capabilities, and this is the important part, right? At the heart of this AWS Glue is a massively scalable data integration engine, which is capable of processing petabytes of data every few hours. It comes in with hundreds of built-in transforms, which helps you integrate data faster. And for any data integration pipeline, the important aspect is how do you monitor that pipeline? And with the built-in monitoring tool, you scale, you build the pipeline, you orchestrate this, and monitor it in real time. I call this batteries included. So it comes with a Hive-compatible metadata store that's, again, massively scalable, capable of processing and identifying and cataloging petabytes of your data. It comes in with Glue crawlers. Now, crawlers are interesting because they are capable of identifying a schema. You can write your custom classifier. It comes with built-in classifier. And it helps you populate your data catalog. And lastly, lake formation. Glue integrates natively with lake formation, which allows you to have data governance around your data lake. It supports ACID transactions. And it basically helps you create that data lake very fast and apply the right access control policies on your data. This is a new topic. Again, line of businesses are requesting that you allow data integration and you support data integration from brand new sources. So these are your CRM data stores. These could be new warehouses that you want to integrate with. And to support that, there are bunch of built-in connectors. And this is another interesting part that Glue supports built-in connectors and exposes the right set of APIs. And this is something which we did last year, where we exposed right APIs on Glue, which delivered a couple of things, right? Number one, it allowed third-party partners to actually build connectors. And these data connectors are, again, scalable. They are supported by third parties. They are available on AWS Marketplace. They've gone through the vetting, and they work. And it comes with enterprise support. The second thing with the APIs delivered is it allows customers to build their own data connectors. Now, every enterprise has a data store which no one knows how to connect to. And the idea with the APIs is that you can write your own connector and connect to that data source and ingest data from that source. And lastly, user productivity and data operations. Now, Glue supports a broad variety of persona. Every enterprise is growing. They are requesting more users to be part of their data journey. And as part of this data democratization, you are opening up your data lake to a broad set of personas. You are looking at developers. You are looking at visual job authors. You are also looking at SQL analysts. And all these personas have different skills, they have different desires, and they are comfortable using different tools. And with Glue, it offers it all. So with Glue Studio, you can create visual job authoring. Previously, you might have heard Swami talk about notebooks. So this is a brand new feature on Glue, which allows you to write your data integration job right from the Glue Studio notebooks. And through Interactive Sessions API, you are able to connect the development tool of your choice to the APIs and develop your data integration job. Now, building the pipeline is one thing. Orchestrating this pipeline is yet another set of challenges. Now, what Glue offers is a set of workflows. And these are workflows which help you orchestrate these pipelines. Now, for example, a typical ETL pipeline involves crawling the data store, populating the metadata catalog, and then running your set of transforms. Through the Glue workflow, you can automate all that. On top of that, you can trigger that workflow on a schedule. So you can say, this job needs to execute every day at this certain time, or every week at certain time. That's possible. That's a common pattern. There is another pattern which is emerging as customers are relying on these data lake for their business insight. These are called event-based workflows. And this is another feature that we delivered last year, which allows customers to trigger a workflow based on certain event. A common pattern there is that as soon as X number of files land on S3, you want to trigger a workflow. And that feature, as part of orchestration, that allows customers to have these data ready in their data lake at the right moment. So, key capabilities around scalable data integration engine, connectors, data catalog and governance, and data operations. As I mentioned, there is an interface for every persona, and here's the beautiful part of it. Regardless of how you author your job, you get the benefit of massively scalable Glue execution engine. In the background, whether you have authored your jobs through Visual Tool, whether you have authored or uploaded your own script, or you have written this through Notebook, Glue converts those jobs into a very scalable and scalable query plan. It converts it for the most optimized execution and deliver it on the massively parallel execution engine. So let's understand the mechanics. And this is where we are going to go inside the execution model. What happens when you author your job and submit it, whether you submit it on the Visual Tool or whether you use an API or CLI to submit that job. So number one, it's a serverless data integration, which means you do not have to worry about infrastructure management. You upload your script, you author your job, and that is it. It's fast and predictable. And this is very, very important. So this is where Glue has done a bunch of innovation which help scale your data integration job across hundreds of clusters. Specifically, the time to first query or achieving the time to first query of under a minute. Now, what is important here is that through the innovation done on the job manager, we are able to scale to hundreds of clusters regardless of the size of the data, regardless of complexity of the transforms, whether you're executing 5 transforms or 100 transforms, where your data is measured in gigabytes or petabytes. You get this fast start time regardless of the size of your data integration workload. And lastly, cost effective. Now, you only pay for the duration of your job. We automatically scale up the required resources, process your job, and terminate those resources. And this is on-demand, per-second billing. Now, I talked about the purpose-built job execution engine and a scheduler. We also run a performance-optimized Spark version. We support, last year we delivered vectorized SIMD CSV readers for even better performance. And Spark Shuffle Manager. Now, this is another interesting thing. If you're familiar with Spark, you understand that there are challenges with out-of-memory errors. With the Shuffle Managers, you can actually avoid all that. Glue will identify those errors and ensure that that didn't happen by spilling the data over to S3. And lastly, but not least, fine-grained access control through lake formation. Now, we don't have time to talk about all the innovations that Glue has delivered. There are a bunch of blog posts and sessions that are done in past, and you can refer to those. So now, let's talk about the execution model, right? So when the job is submitted through Job Manager, job is divided into multiple stages, and data is divided into multiple partitions. And each task, or Job Manager basically schedules the task on various workers. It automatically figures out which worker is going to execute which task, and it is capable of scaling this up to thousands of workers. Now, we establish the execution model. We talked about all the capabilities that Glue has. We talked about the fast execution and massively parallel engine. And we talked about the personas that are writing these jobs. Now, the need for auto-scaling emerged from the fact that businesses, whether these are planned business events or unplanned business events, all these events trigger changes to your data personality. Now, what do I mean by planned event? Last week in US, or actually this Monday, there was a tax day. This was a planned event. Everyone knew about it. But the size of your data increases due to this. There are events where line of businesses are requesting ad hoc processing. They just identify a new data source, and you as a data engineer is now responsible for ensuring that you are able to process the data from this new data source. Maybe the application developers decided to drop a column or add a column in the application, which changed the data personality. In all these cases, you have schema variance, you have size variance, and maybe you are dealing with brand new sources. That triggers changes to your capacity calculation and in turn your cost calculation. Now, what is difficult about capacity? Predicting demand is very hard. It's very difficult to pinpoint how much incremental capacity you will need to process that incremental fraction of data. So your resource demand changes, your data volume changes. Sometimes tuning is required. Maybe you added a new transform. Maybe you are doing an ad hoc analysis. In all these cases, you have to probably tune your resource requirement based on the ingestion, based on the data personality. And then there are trade-offs. Now, the trade-offs are are difficult trade-offs. Should you over-provision the resource for all the eventualities? In those cases, your cost will go up. Should you under-provision the resources to ensure that cost is within the bound? In those cases, there is a high probability of job failure. You are basically increasing the probability of failure. This problem is something which is regardless of how well established your data integration processes are. Because of business events which are outside your control, you are constantly in need to tune your data integration pipeline. So we just announced Glue Auto Scaling. The objective of Glue Auto Scaling is to reduce cost, adjust automatically, and simplify the capacity planning, so that as a data engineer, you are only focused on developing new workflows, identifying new data patterns, writing new transforms, and you do not have to worry about capacity planning and resource provisioning. How do you enable auto-scaling? There is two simple checkboxes. There is actually one simple checkbox on the UI. And on API and CLI, you can just enable a simple key value pair. So now let's look at a couple of examples of how auto-scaling works and how does it solve this capacity management problem and the cost problem. Let's take one example where job contains multiple stages. You are creating an ETL pipeline where data is coming in from JDBC source, and you're writing it into Amazon S3. This is a common pattern, and it's a good example where we are going to walk through what are the different stages of a data integration job with Glue. So now the typical pattern is that you do not want to tax your JDBC source. That's why the idea is that you have fewer connections to the JDBC source to avoid burdening it with processing those analytics workflows. So at the first stage, you just open it up with fewer connections, and then you try to achieve parallelization at the later stage. Now, you read the data. You want to write a custom transform. You maybe want to add a column. Maybe you want to drop something. And then you want to apply mapping and write to S3. So a best practice design here is that you need to have fewer resources, fewer connections at the beginning of the pipeline when you're reading data from JDBC source, and you achieve higher parallelization at the later stage so that you have the most efficient experience. Now, how does it work today? So without auto-scaling, Glue will start the driver node. It will automatically provision your data integration cluster. And those resources stays constant throughout the life of the job. Now, with auto-scaling, driver only requests fewer workers. And these workers are responsible for ingesting the data from JDBC source. And then as the demand of the job increases, as you are applying transform, as you are writing to S3, driver requests more workers. And this gradual scale-up reduces the compute required for the entire job. And as a result, you have lower cost. How does it look on your Spark UI? So as you can see at the beginning of the job, you're reading from the JDBC source, and you can see executor 1 and executor 2 added. And for next 10 minutes, as those two executors are reading the data from JDBC source, you do not have additional workers added. And towards the end of the job, or actually in the middle of the job, you added 3 more workers to do additional transform. And towards the end of the job, you added more workers to write to S3. This way, the total compute requirement for the job reduced significantly. And your cost of processing, in turn, reduced significantly. In this case, you don't have to have the computation. You don't have to do any calculation around how many workers you need. You can start the job run with X number of worker, and Glue will right-size your cluster for the most optimized and most efficient job run. There's a second example with small files. Now, small files are always a problem, had been always a problem when it comes to processing. One of the big challenges is that by default, Spark assigns one task to one small file, and it leads to listing issue. You basically have to list all the files. It leads to metadata problem. It leads to those explosion of partitions. In all these cases, right, Glue has over years innovated. So we have added features which allows us to process a large number of small files more efficiently. One of the good example is Pushdown predicate. Now, in your data lake, suppose, and this is again a common pattern, you have partitions based on years, months, days, hours. And suppose you just want to process, you want to do a year-over-year calculation. So you want to compare the sales data of January 2020 to January 2021 to January 2022. For those cases, you don't want to request the entire data lake. You want to just apply a filter, request the required data. And where Glue delivers something called Pushdown predicate, where you can apply this filter, and Glue will only request those data files. And it will filter out all the unnecessary partition. The second optimization is file grouping. Again, in this case, what Glue does is it groups the file into manageable chunks, and then each Spark task processes those groups of files. These are just a couple of examples. In general, there are other innovations that Glue has done. File grouping, partition index. There is a custom S3 lister. And all these innovations are managed by the driver. So in this case, driver is coming up with the most optimized query plan for workers to process throughout during the job data integration. So now let's look at what happens with and without. So without auto scaling, again, Glue will provision the required worker, and those workers will stay constant throughout the duration of the job. With auto scaling, and in this case, the cost of your data integration job is the function of compute times the duration. Now, with auto scaling, driver is doing all these optimization. Driver is looking at your query, reducing the number of partitions, filtering out unnecessary partition. It's identifying the right grouping based on an input or based on your data transform. It's doing some of the other optimization to come up with a perfectly optimized query plan. During this time, Glue will not provision any worker. You're only charged for the driver compute node. And once the driver has done the optimization, done the query planning, it will call the required set of workers only to process the subset of the data. And in this case, your cost is compute times the duration. So as you can see, between with and without auto scaling, there are significant cost saving that you can achieve. This is what it will look like on the Spark UI, where at the beginning of the stage, you have fewer executors. You just have one executor for an off chance that your Spark driver wants to execute some task. And for 40 minutes, Spark is just listing, driver is just listing the partitions. And we have not provisioned any executors during that time. And for the final stage of the processing, Spark then calls up, and Glue driver that calls up the required set of executors. In this case, it's around 15 to process that data and write the files into S3. So putting this all together, when you start your job, your cost is a function of the compute used. So at the setup stage and without auto scaling, your total cost stays constant throughout the job. And with auto scaling, depending on the stage of the job, depending on whether you are performing a write transform, whether you're listing files, whether you're reading from S3, or whether you're writing, Glue will automatically provision the right set of compute resources, thereby significantly reducing your data integration cost. So now available, AWS Glue Auto Scaling. It allows you to reduce cost and simplify the capacity planning. Thank you.